Stretching over 3,500 miles across Wyoming stands the oldest land reserve in the United States. Our group, consisting of Emma Nales-Torchio, Joshua Skipper, Genesis Ramos, Bryce Fox, and Blake Thomas, decided to study this remarkable area of geological interest. We will present the geological map of the area, the geological history of the area, and some interesting facts. But to begin with, we will start discussing the geological map.
This is an example of a geologic map of Yellowstone International Park. As you can see, the park contains many geographic characteristics. The tan part of the map is known as the Quaternary Alluvium. In other words, it's the thermal areas within Yellowstone National Park. These are the areas thought to be responsible for geyser activity within Yellowstone National Park, although not all of these areas have geysers. You can even see one of the most famous geysers, Old Faithful, within the yellow highlighted area. The pink represents large deposits of igneous rhyolite from eruptions that previously happened. The area of the map which is gray represents basalt deposits left over from volcanic activity from thousands of years ago. The area highlighted in orange is known as tuff. Tuff is formed through pyroclastic materials such as ash from previous eruptions. The area of the map highlighted in red is known as tertiary intrusions. As we know, Yellowstone National Park is known as one of the world's biggest supervolcanoes. The highlighted blue on the map represents areas of the map that have previous volcanic or current volcanic activity. The area of the map highlighted in purple represents the Paleozoic and Mesozoic sedimentary rock formations. If you look at the red stripes presented on the map, that represents the edge of the Yellowstone caldera, which is an indent in the ground caused by volcanic eruptions. The black lines you see scattered everywhere on the map represent geological faults within the park. Looking very similar to the faults, there are some black lines that form crosses, which represent folds within the park. And finally, the solid black lines seen throughout the map represent the roads.
Now we will present a few interesting facts about the area.
Yellowstone has 1,000 to 3,000 earthquakes annually. Yellowstone National Park sits on top of an active supervolcano. Although this park system believes that it's unlikely to explode again within the next 1,000 to 10,000 years, the park is one of the most seismically active areas in the country, experiencing between 700 and 3,000 individual earthquakes annually. Yellowstone has one of the highest lake elevations in North America. Yellowstone Lake is situated at 7,733 feet above sea level, making it one of the largest and highest elevation lakes in all of North America. Yellowstone has more than 300 active geysers, more than 290 waterfalls, and more than 1,800 archaeological sites. There are over 1,000 species of native flowering plants, and there is also 5 park entrances and 466 miles of road. One of the most famous gushing geysers in Yellowstone is called Old Faithful. This geyser spews water 180 feet into the air. These days, the gusher often takes breaks as long as 90 minutes in between eruptions. It is also home to hundreds of animal species, including bears, wolves, bison, elk, and antelope. The roughly 5,500 bison that live in Yellowstone today constitute the nation's largest and oldest free-range herd.
Moving on from the interesting facts, we're going to take a look at the geological history.
The geological history of Yellowstone National Park. Due to crustal plate movement, scientists have been able to prove that convection currents move the crustal plates above. Yellowstone is a product of plate movement combined with the upwelling of hotter, semi-molten rock. A large amount of magma was pushed through the hotspot onto the Earth's surface. By this happening, the Earth's crust would stick out in an upward position. So much pressure was being built up on the surface that there was a large release of magma underneath. Because the area under the surface was now empty, the crust caved in. This created a caldera, which is the result of a volcanic depression.
The Yellowstone National Park has many different geological features. However, many of them are not even able to be seen. For example, at the Yellowstone National Park, there is a hotspot where the plates from plate tectonics move. This allows the thermal energy to be released from the core out. Yellowstone contains 10,000 thermal features and between 300 to 500 active geysers. It contains thermal features that show evidence of a continued heat source not far from the Earth's surface. It provides heat for Yellowstone's geysers and hot springs. Here, Earth's crust has been compressed, eroded, and subjected to volcanism. All of this geologic activity formed mountains, plateaus, and canyons that define what Yellowstone National Park really is. Yellowstone National Park preserves more than 10,000 hydrothermal features. An extraordinary collection of hot springs, mud pots, and terraces make up the park. One of the world's largest active volcanoes lies beneath Yellowstone. The first major eruption of this volcano occurred over 2.1 million years ago and covered over 5,000 square miles with ash. It's among the largest volcanic eruptions known, and it marks Yellowstone as a supervolcano. Also, there's a Grand Canyon of Yellowstone. Created from erosion of the Yellowstone River, the canyon is from 1,000 to 4,000 feet wide, 20 miles long, and over 1,000 feet deep. It provides the endless views to all of the people who come to see it. Around 40 to 50 million years ago, widespread volcanism, seismic activity, and mountain building produced the Absaroka Range, which borders the park's north and eastern sides. The pressure from the magma deformed the land of the caldera but in two domes. These domes, known as Sour Creek and Mallard Lake domes, occur as the pressure in magma chamber increases. This causes the land to lift above it, and as magma or hydrothermal fluid leaves the chamber, the domes drop back down, which continues to shape the landscape. About 16 million years ago, heat convection in the mantle caused a plume of hot magma to rise. This melted the rocks and heated up the crust along the way. This plume came to rest and created a reservoir of magma, the source of heat and energy that caused the massive supervolcano to erupt.
After viewing this travel vlog, we hope to have successfully informed you on this geological national park. and all of the anomalies that the park contains. We thank you very much for watching and for staying to learn about this geological wonder.